Good afternoon, everybody. It's Lee Cassidy. I'm going to do In the Hot Seat with Lee Cassidy, interviewing Lee Cassidy today. And I'll explain how I'm going to do it in a little while. I've thought of a few different ways of doing it. But first of all, what I'd like to do is just go through a few things that we're doing this week. So tomorrow, we're going to do an Enterprise Wednesday talking about risk and compliance. A lot of organizations are really concerned about compliance and looking at the level of risk in their organization. So we're going to focus on those two things tomorrow and some of the ways that you can actually manage that risk and also look at controlling compliance. And when we look at compliance, it could be internal compliance from a security perspective, but it could also be external compliance, such as, keeping in line with CIS or NIST, IT-based security practices, or it could be PCI or HIPAA, the equivalent in the UK for patient records, so people have got that in mind as well. On Thursday, we've got Ben Grouchy of eCruit, who's one of the Goldman Sachs alumni who went through the program in the past and is in the hot seat with the 10KSB, which I do on a Thursday at 3 p.m. Then on Friday, we're going to do a physical security session, and we're talking about number plate recognition and how you can use number plate recognition in different applications and different ways that you can do things. So that's that over, and let me explain a little bit about what I'm going to do then. So I thought about effectively having two camera angles and looking across at different cameras and asking myself questions. I thought that would be stupid. I thought about effectively recording the questions in advance. So I just kept playing and pausing, going through, asking myself questions. And again, I thought that was stupid. What I'm going to do is just effectively go through what I would normally do when I interview someone else. So normally what I kick off with is, tell us a little bit about your background, where did you start, and a little bit of how you got to where you are today. So let's talk about that first. So I'm originally from a place called Maltby in South Yorkshire. I was born there in 1962 in November, and it was the year of I think one of the worst winter storms and heavy snow as well. So a good start to my life out there. I was brought up there, 17 years. I went to school and studied the usual things, but I focused around maths, physics, and chemistry towards the end. And I had an idea of going off and studying metallurgy at Loughborough University, but I'd also spent a lot of time thinking about becoming a pilot and trying to become a pilot in the Royal Air Force. And I'd done a little bit of the selection training, and I'd also joined the Air Cadets at 218 Rotherham Squadron, and spent some time there in the 70s up to joining the RAF eventually in 1980. So what happened with that is I just got to the point where I thought, I don't really want to do any more schooling. I've done, got towards the end of my A levels, and that was enough for me. I didn't really want to go to university. So I went to the Careers Information Office and I said, tell me a little bit about the type of job that you could, I would fit into. So at the time they did a little test to see what I was suitable to work in, and it came back that I fitted really well for a particular role they'd just been recruiting for, which was at that time an LTEC ST. I'd never heard of anything like it. It was complete it's like a TLA on steroids, and I had no idea what a LTEC ST was. But then they explained it was an electronic technician synthetic trainer, and a synthetic trainer is a flight simulator to the rest of us. So we just call them flight simulators, but in the military they're a synthetic trainer. So the idea was to work as an engineer maintaining those simulators. As you know, most simulators are made up of a large number of components, and there's quite a lot of training involved to get there. So I went off to RF Swinderby, which where you do your basic training. So learn how to polish your shoes, press your shirt, press your trousers, how to march around, how to use a rifle, all the basic things that you have to do when you join the military. Lots of injections, which is as fun, especially when they give you 4 just before you do drill, and then eventually finished there at the end of, I think it was about just towards the middle of December of 1980. Went off to RF Locking, which was originally down at by was it Western Supermare, just on the outskirts of Western Supermare, and started off with my ground training, learning about simulation. So it was, understanding flight. How does an aircraft fly? What about all the equipment, the systems within an aircraft? How do you then simulate that? So using software, but also looking at it from an analog perspective, because there were still analog simulators. So went through all that and then added the military piece on top of that, because military flight simulators also have things like missiles and gun packs and things that you would use that you wouldn't see in a traditional civilian flight simulation environment. So a few different things there. Learned all that, and then I was posted on one of the oldest simulators in existence, which was the BAC Lightning simulator out of Bimbrook over by Grimsby. So it was a completely analog simulator. So it was all what we call servos, so effectively a motor with a feedback loop on it, with different amplifiers, which did either differentiation or integration in mathematical terms with those voltages, to be able to drive these servos up and down. So you had one that effectively worked out, say, the altitude you were at. And because of the altitude, it would know what the air temperature would be, what the air density would be. And from that, it would actually know how much thrust you would get from the engines with the engine at a specific setting. So we do all that simulation and mathematics with, effectively electronics, but really old electronics using valve amplifiers. So we've got lots of valve amplifiers in there and lots of very high voltages as well. It's not like computers of today where the most you're getting up to is maybe 24 volts. A lot of this was up to 500 volts because we're driving across these, valve systems, so very, very high voltage, but quite low current. But if you did touch something, you knew about it, you could feel it. Did that for a few years, and then I moved to RF Lynham and worked on the Hercules simulator, which this was a fully digital simulator. So I went on another course down at RF Locking on a specific computer system called a Perkin-Elmer, learned how the Perkin-Elmer worked. Went to went to Lynham, and then did on-the-job training. So learned about the simulator while I was there, because there was no effectively trade course for it. So you did all your training on the job. So learned about how everything fitted together. Talked about the computer systems, the Perkin-Elmers. There was a PDP. There was a visual system based on some of the newer x88 processors at that point in time. So this was really early days of the x86 and x88 range that we see nowadays. It actually had a parallel processor. So you would throw data in one end and it would go through this process and back and forward between all the different x86 boards and work out what to present on the screens in front of the crew on the flight deck. So really interesting technology at that time. Also, hydraulic systems this time, instead of what we had on the Lightning, was really basic. It just had what we call TNA frame, so it could move up and down, tilt forwards and back, so pitch, and it could roll right and left. That was all it could do, 3 axes of motion. With the Hercules, it could do 6 axes. So what you would be able to do is not only pitch up and down and rise up and down and roll, you could actually rotate, and you could go forwards and backwards, and you could go sideways as well. So through that, you could simulate anything. And just talk about how these systems work. So to simulate acceleration, what we would do is you would bring the actual cabin back using software, and then you would push it forward. So you got that surge forward, and then you would tilt the actual flight deck up. So you got weight of your own body and gravity against the seat, bring it back, and then go forward again. You keep doing that, and it feels like you're actually accelerating forward using that. So really interesting. We did 4-hour missions on it with the crews. The simulator was run majority of the time. It was really, we handed the aircraft over about 7 in the morning, and then they would give it us back commonly around 2 in the morning after that a number of crews through, and then we would have to look at what the issues were that had been reported previously, what the new issues were, and then we go and fix it. and work out what the problems were. We also did changes in simulation. We had to change how certain things worked. I did some work on the software to modify how the turbine gas temperature gauges operated in a start sequence. They weren't quite right, so we did some modifications for that in software. And we did other things like updating the visual system to have different types of things in the actual airfield. So we could put new lights in, we could do new strips, we could put in different vehicles that moved as well. So lots of work in that space. I moved then on to the Tornado Grand Attack, the GR1, which has gone out of service now. So very similar to me, I've gone out of service and it's just gone out of service. Worked on it at RF Bruggen in Germany. It was a modular simulator, so it was actually in containers. So we did everything. So the 3-phase power came into the building. We did everything from 3-phase through to the 5 volts driving the logic boards and in the computer systems. We did all the hydraulics and pneumatics, everything that was required to create that simulation. So all the way through. I was specialized in flight, which was managing all the hydraulics and the flight systems and all the computer systems that drove that portion of the simulator from the flight container. There was also an avionics and a drillums container. So avionics was all the backseat navigation system and avionics, and the drillums was the simulation of the radar systems that are on board. So there's 2 radars, a mapping radar, and also there was a terrain following radar. So it simulated both those in that system. So again, we used to full missions. Again, as simulator engineers, we would fly quite regular, because if they told us what was wrong, we had to then go and simulate it and see what happened when we did it, and then we could actually work out what the problem was and hopefully fix it afterwards. So it was really interesting working in simulation. I also moved back to the UK and stayed on the Tornado and worked at RF Marham out in Norfolk by King's Lynn. Then I moved over to RF Cosford for my last 3 years teaching in the ground school. I'd worked with a team that we took effectively the course design and turned that into an actual training course. And then we delivered it to a number of students who came through, where they were effectively basic level mechanics working on simulation, and the idea was to take them to the next level and then them go back as an engineer. So we would work with them for about 26 weeks out of the total time we're there. I focused on the computing components and diagnostic work in that space. When I left, it was mainly because we'd been made redundant. There was 500 of us and we were all made redundant in one time. So anyone who was on a simulator just went off home, came back in their civvy clothes and carried on working under contract to a company called Hunting's Engineering. Had the initial contract. I think it's gone through a number of iterations since then. And anybody who wasn't a sim had to find a job. So I was working at Cosford on training, so no job to go to. So I went off and looking for one. I ended up working for a company based in Solihull, of all places, just down the road from where I live still now. And it was a software company that specialized in interaction with mainframe systems, and worked with them for a couple of years. Then I went to work for a similar company called Wall Data, who did similar things, but predominantly on the IBM mainframe side rather than ICL mainframe, which the company in Solihull did, and worked quite a bit in the US, because the first business, they were acquired by a company that was based in North Andover, 25 miles north of Boston in Massachusetts. And the second company was based in Kirkland, over by Seattle. So did quite a bit of travel over there and back as well with that job. Later on, worked for IBM, did some time there around application service provision, which today we call software as service. And then after that, worked for Sun Microsystems, predominantly in the migration of applications from mainframes onto the Solaris platform. But later on, I was absorbed into the large-scale computing team and did majority of the work around selling large computer systems. So the E10K and the F15K, which were the very large computing platforms that Sun Microsystems had at the time, selling to large organizations like GWP and those kind of organizations. After that, I decided in 2004 I'd like to work for myself. be a bit more of a master of my own destiny. So I set up a business originally to try and do project management and teach people to run their IT projects more effectively. But what tended to happen is people just asked me to do the job for them, so I did it for them rather than actually getting them to do it. I did quite a few pieces of work around IP telephony, when the early days of IP telephony around 2005, 2006, and set up a platform for one of the organizations I was working with, and effectively worked as their IT director for a couple of years. Eventually, the company had to shut down. They weren't generating enough money. So what I did was take those IP telephony customers and move them into my business. And I'd also set up another business doing software as service for document management at the same time, and ran those two businesses in parallel. So focused on IP telephony, video conferencing, and managed data connectivity in one business. And the second business, we were doing document management, but we found quite quickly that it was quite difficult utilizing just physical Linux servers to actually deploy a customer very quickly. So what we started to do was utilize a new thing at that time called VMware, which was a virtualization technology. So what we could do is use this to actually get a customer set up by using a pool of infrastructure, and it was version 3.5 of VMware. So anybody who's familiar with VMware will know it wasn't the best platform at the time, VMware Server, but we could actually get a customer provision in about 6 hours rather than it was taking us 2 to 3 weeks by the time we got equipment in and gone through the process. So it made life a lot easier. We continued running both businesses in parallel, but when we got to 2010, we realized we were never going to be rich just actually running a document management service. A lot of people were starting to offer these things near for free. So we decided to use our experience with virtualization and actually start selling products and services around that virtualization rather than just doing a service with it. So we started to focus in that space. In 2014, we merged the two businesses together because effectively we've been running them as two separate businesses with one set of staff, and we were actually just using monopoly money, moving money between the two businesses. So it was pointless to run them independently. So we decided to bring them together, and that became just Tactile Technology at that time going forward. We've always been very innovative in our approach. So we've always looked for the best technology, the most innovative technology that's going to be disruptive in the space. So we work with a lot of really interesting technologies, such as Tintri when it first came into existence and available in the UK. Meraki, which was a cloud-based Wi-Fi platform initially that came out of MIT, but then grew into a cloud-based security and switching platform. We're working with some really modern technology still, and Tintri still. We've had a relationship with Tintri for over 10 years, and we've sold a lot of infrastructure into organizations. But we're seeing some changes in how people are thinking about storage nowadays, and there's really some adoption of new techniques and technology in that space, especially around NVMe, which is a really fast solid state type of storage platform, and we've seen a lot more adoption of NVMe as we go forward. We're also seeing some real needs around cloud native. So we've started to develop some services around cloud native, so container workloads that you could run on premise or in a cloud environment. And about 3 years ago, originally 5 years ago, I was introduced to a program called the Goldman Sachs 10,000 for Small Business program, which was like a mini MBA for people who are running businesses, and the business have been around for at least 3 years, and we're turning over a minimum of £250,000 at that point in time. So I went on that program, learned a lot about how to, better utilize the learning within the business, how to focus on managing the business going forward. And as many other people have been on that program, I've seen it really is advantageous from an individual, but also from a business perspective as well. But also you have alumni events afterwards. So there are different events going on around the country that you can go to. So I went on to a number of alumni events, And one of them, I met up with someone who'd been on a program called the Advanced Services Group at Aston University. So I started working with that group about 3 years ago, and looking at how we can move from like the basic delivery of a product with a break fix type service, and how we could enhance that and deliver more advanced services to organizations. And over the last 3 years, we've been continued to do that. So we were doing about 20% of our business in services 3 years ago. We're much more like 40% now, and we're looking to achieve at minimum 50% at some point in the near future. So we're looking at how we can do that, but also making them advanced services, meeting a need, a capability for the end user, rather than just providing some basic type services that the customer might need. We're also expanding in this cloud native space, as well as in the traditional cloud, using virtual machines within cloud, by building in AI ops type services. So artificial intelligence for operations, so we can automate the process of monitoring and managing infrastructure, patch management, and the automation of remediations, or fixing problems within IT infrastructure. And we're also looking at extending that into other infrastructure. We're also providing an on-site platform for Kubernetes, which we think is a big area. So we work with a technology called Diamanti, which have got 3 and 4 modular capabilities that allow organizations to deploy Kubernetes locally and also across cloud-native environments in public clouds such as AWS, Azure, and GCP, Google Cloud Platform as well. We're also working with a technology that provides more security in that space as well, called StackRox, and looking at other ways that we can actually monitor and manage these environments, especially in that open source space, but also delivering services in that space as well. And we've continued in the traditional environments to do that as well with our virtualization delivery of service as well. So a lot of things we've been doing moving forward. Hopefully that's given you a bit more of a picture of myself and what I do. Be very keen if anybody's interested in learning more about what we do. So I'll just put up my contact details. So if you do want to contact me, my email address is there, lee.cassidy@tactiletechnology.com. Also our website, www.tactiletechnology.com. If you want to know more about what we do, or a bit more about myself, quite happy to have a one-on-one conversation over Zoom or Teams anytime you like, to learn a little bit more. And also, if you want to learn a little bit more about what we can do for you as a business, quite happy to do that as well. So thank you very much for your time today, for those who've joined me. It's been a pleasure to talk to you. Like I say, we've got other events this week and next week. So a couple more this week, 3 more events this week, and then what we do on a Friday is a quick recap of what we do in the following week. So we do that normally around about 10 o'clock on Friday. So we'll do that later this week. So thank you very much. All keep safe in this time of weirdness, and hopefully everybody has a good day going forward. Thank you very much. Bye.